Advanced Algebra 2, Concept 9 Notes, Part 2. Now we're going to look at solving quadratics using square roots. So again, I'm starting with the graphic that we ended with at the end of the Part 1 notes. Just remember, when you solve equation using square roots, we're going to be using properties of square roots. So how to simplify. And then if we end up with a square root in our denominator, we're going to rationalize those. So if you look at A, B, and C, we can solve each of these equations using square roots. When we solve, we need to be sure that we show that we want both the positive and the negative square roots, if that's appropriate. And you can do that by using a plus or minus sign in front of the square root. When doing Math Excel problems, you will probably need to split them up and show both a positive and a negative example. Now, if you look at both A, B, and C, these problems, notice that what we have is either just one x squared expression that we can isolate and solve for, or one x expression, like with a number added or subtracted to it, squared. So in C, for example, if you have quadratic equations that are in this format, then you can isolate the x squared or the x squared expression and solve. So let's look at A. We need to move everything away from the x squared. So the first thing that we want to do is we want to add the 31 over to the right side. When we rewrite, we get 4x squared equals 80. Now we're going to continue to isolate the x squared so we can divide by 4. So now we're left with x squared equals 20. Now to solve for x, we can undo the squared by taking the square root of both sides. So x will equal the square root of 20. So I'm going to simplify that, knowing that the square root of 20 has a perfect square factor in it, 4. So I break it into the square root of 4 times the square root of 5, and then I take the square root of 4. Finally, notice that I show both the positive and the negative square roots, because this is a quadratic that has two x-intercepts. So I need to show the positive and the negative 2 times the square root of 5. Now, if you're wondering where that crosses the x-axis, you can take 2 times the square root of 5 on your calculator and get an estimate. But we're going to solve in exact terms, so we're going to leave it in the square root form. All right, let's look at B. So we can start in very much the same way. We're going to subtract 1 from both sides. So negative 2x squared equals negative 7. Then divide by negative 2. X squared equals 7 halves. We can take the square root of both sides, so x equals plus or minus, and then we can split up that square root, so it's the square root of 7 over the square root of 2. I want to rationalize my denominator, so I'm going to multiply both the denominator and the numerator by the square root of 2. So my final answer is plus or minus the square root of 14 over 2. So notice when I take a square root times another square root, I just multiply those numbers. So the square root of 7 times the square root of 2 is the square root of 14. And then the square root of 2 times the square root of 4 is times the square root of 2 is essentially the square root of 4, which simplifies to 2. Okay, now on number 5, the first thing we need to do is isolate that x squared expression. So we're going to divide by 2/5, which is the same thing as multiplying by 5 halves. So we rewrite and get x plus 3 squared equals 25 halves. Now I'm going to take the square root of both sides. So x plus 3 equals plus or minus the square root of 25, which is 5, over the square root of 2. I'm going to rationalize that square root of 2 in my denominator by multiplying, so I get 5 times the square root of 2 over 2. Now the last thing I need to do to solve for x is subtract the 3 from both sides. And when I do and place it on the right side, I'm going to put it in front of my square root expression. So it's negative 3 plus 5 times the square root of 2 over 2, and negative 3 minus 5 times the square root of 2 over 2 for my two answers. And so that's how you would deal with a problem where you need to rationalize the square root and then add or subtract a number value to that square root expression. All right, let's do a little more practicing with rationalizing denominators. So if we had plus or minus the square root of 13 over 2, we would break that up into the square root of 13 over the square root of 2. Then you'll multiply top and bottom by the square root of 2. So that becomes plus or minus the square root of 26 over 2. If you put that initial expression, square root of 13 halves, on your calculator, and then also the square root of 26 all over 2, they will equal the same thing. You can see that they are equivalent. Number 2, let's do the same thing. So let's rewrite it as the square root of 15 over the square root of 4. Now we can take the square root of 4, which is 2. And so in that case, that's all we need to do to rationalize. Number 3, we'll rewrite it as the square root of 5 over the square root of 3. We'll multiply numerator and denominator by the square root of 3 and get square root of 15 all over 3. All right, that concludes our notes for solving a quadratic using square roots. So remember that this method only works when you have equations that are very much like, let's see if I can back this up, there we go, A, B, and C, where you just have an x squared expression, or an x squared by itself, or an x squared expression by itself that you can isolate, and then take the square root of both sides.